My batteries arrived, and here is what they look like connected up to the charger that came with my hub motor kit. I decided to go with old technology sealed lead-acid batteries of the type that have been well known to modern civilization because they're simple, they're reliable, they're inexpensive. They are, however, heavy. I bought mine on the web, online from jupiterbatteries.com. Here's a picture of their website. And browsing in, it was easy for me to find these. They're prominently featured as one of the very first items listed in their product section. I decided to go with 7 ampere-hour batteries, 12 volts apiece. So when I connected 3 of them in series, I obtained the requisite 36 volts needed by my motor, and for which my charger is compatible. It was easy to hook them up. I found that the spade lug connectors that came on the batteries were compatible with lots of crimp-on connectors I could buy over at Home Depot. I ended up buying a hand crimping tool, and that made it really easy to, and I also got the hookup wire there at Home Depot, and that made it really easy to crimp on the connectors that you see here and create a system to charge them up. And I used the same technology for connecting them to the motors. On the charger, it takes basically 6 or 7 hours to charge the 3 of them up, and I was pleased to find that they don't get hot and the charger doesn't get hot during that process. And I find if I leave it on for several days afterward, they still don't get hot, and that gives me a lot of confidence that the charger is not going to burn up these batteries. Each battery weighs about 5 pounds, so the 3 of them together add about 15 pounds of weight to my bicycle. It's getting heavy, but it's worth it. Now you can see from this photo the way I've arranged the batteries to be connected in series. The battery on the left has the most negative potential. The one on the right has the most positive potential, and the one in the middle, of course, is neutral. So the battery in the middle has its negative electrode connected to the positive electrode to its left, and the battery in the middle has its positive electrode connected to the negative electrode to the battery on its right. That way the voltage kind of stacks up and gives me the 36 volts that I need. I noticed that the power supply, or the battery charger, was color-coded so that the red wire coming out of it came through a fuse and through another red wire, and I connected it through a crimp-on connector to the red pole, the red electrode of my most positive battery. Likewise, the other wire was green and yellow, which is often used for negative, and I connected it to the black connector on the most negative of the 3 batteries. I decided to wrap some black electrical tape around the end of that so I'd have a kind of a black end to remind me if I ever get confused to use black to black there. The other wire you see coming out of the power of the battery charger is just mains power, and it connects to my United States mains electrical power. In my case, it's 115 volt AC 60 cycle power, but it's an international charger and is designed to adapt to other power arrangements. Overall, I'm pretty happy with it, and the batteries charge up nicely. I like it. Having trouble finding the rest of the video clips in this series, or getting confused with similar clips from a different series? Well, the easy way to sort this out is to come join us at AskMisterWizard.com, where they are all nicely arranged with accompanying text, some useful still shots, some tips about bargains when you're buying the tools and supplies, and also advertisements from people that sell bicycles and motors and tools and wires like this. Join us there, please.